Hey there, 6th grade data detectives. Welcome to another exciting explainer. Today, we are going on a really special mission together. We're going to learn how to solve actual, real-world mysteries using the absolute superpower of math. Have you ever looked at a massive, totally overwhelming jumble of numbers and thought, what on earth is this actually trying to tell me? Well, you know what? By the time we wrap up today, you'll be able to decode those numbers, spot hidden patterns, and present your findings like an absolute pro. Okay, let's dive right into this. So, here's our mission briefing for today. First, what is data? Second, organizing data. Third, pictographs. Fourth, bar graphs. Fifth, art and data. And finally, a quick revision quiz to wrap it all up. All right, section 1, what is data? Understanding our clues. Picture this. Two students, Navya and Naresh, are having a pretty heated debate. Naresh is totally convinced that cricket is the most popular sport in their class, but Navya, she isn't so sure. So to settle it, they go around and ask every single classmate for their absolute favorite game. And what do they get? They end up with this huge, messy list of names. Kabaddi, hockey, football, Satolia, cricket, just all jumbled together. Looking at that raw, mixed-up list, it's honestly really hard to tell which game actually wins. But this messy list, this is our raw material. And that brings us to our very first major clue. What Navya and Naresh just collected is called data. Data is simply any collection of facts, numbers, measures, observations, or even just descriptions that convey information about something. If you went and asked your classmates for their favorite colors, boom, that list is data. If you measured the weight of everyone in your class, those numbers, also data. It's literally the information we use to answer questions about the world around us. Moving right along to section 2, organizing data, making sense of those clues. Let me tell you a quick story about a teacher named Srini Lesh. He wanted to buy some sweets for his class to celebrate the new year. He gave them 5 choices: jalebi, gulab jamun, gujia, barfi, and rasgulla. Now, instead of writing down a chaotic list of names, he was smart. He organized the data right on the board using a table and tally marks. And notice how these tally marks work, because it's super clever. For every student who wanted a specific sweet, he drew a straight vertical line. But as soon as he hit the 5th student for that sweet, he drew a diagonal line right across the first 4. This visually groups the choices into neat little bundles of 5. It makes counting up the final total incredibly fast. You literally just count by 5s. 5, 10, 15. So the really crucial point here is that when we count up those tally marks, we arrive at a specific number. For instance, Gulab Jamun had exactly 9 students choose it. In the world of data detectives, we actually call that number the frequency. Frequency is just a fancy way of saying the count of how many times a certain value or observation occurs. So the frequency of Gulab Jamun lovers in Srini Lesh's class? It's 9. Let's look at another awesome trick for organizing numbers. Sushri Sandhya asked her students for their shoe sizes, and of course, she got a totally jumbled list back. 4, 5, 3, 4, 7, 6, just a total mix-up. To solve this headache, she arranged all those messy numbers in ascending order, which just means from the smallest to the largest. Suddenly, by lining them up nicely like 3, 3, 3, 4, 4, 4, and so on, it became magically easy to answer questions. What's the smallest size? Well, just look at the start of the list. It's a 3. The largest? Look right at the end. It's a 7. Organizing your data is a lot like cleaning your room. Suddenly, everything is just so much easier to find. Let's hit section 3, pictographs, visualizing with pictures. So a pictograph represents data using simple pictures or objects. Honestly, instead of staring at boring plain numbers in a table, a pictograph lets you understand the entire dataset completely at a single glance. It's kind of like turning math into a really cool comic book. But hold on, because here is the absolute most important rule of pictographs. You must always look for the scale or the key. You see, one picture doesn't always equal just one single item. In a library dataset, for example, the key might tell us that one single picture of a book actually represents 10 borrowed books. So if a pictograph has 3 book icons sitting next to Monday, that definitely does not mean 3 books were borrowed. It means 30 books were borrowed. All right, let's test your skills for a second. If you're looking at a library pictograph and the row for Thursday has the absolute fewest number of book icons, what does that instantly tell you about Thursday? Take a second and think about it. Yep, that's right. It confirms right away that Thursday had the minimum number of books borrowed that whole week. And the best part? You figured that out without doing any actual math, just by looking at the pictures. Moving to Section 4, bar graphs. Precise data towers. Building a bar graph is actually a bit like building a city of perfectly neat little towers. But you have to follow some pretty strict rules to get a permit. First, every single bar must have a uniform width. They all need to be exactly as thick as each other. No exceptions. Second, you must keep a uniform, perfectly equal gap between each of those bars. And third, you have to choose a suitable scale along the side, like counting by 10s or maybe 20s, so that the heights of your bars actually make sense.
And this is exactly why those rules matter so much. Think about a bar graph showing how many tree saplings a school planted over a week. When you follow the rules, it looks so clean. The days are lined up on the bottom, and the numbers are on the side, climbing up steadily by tens. Just by quickly glancing at the heights of these colorful bars, you can instantly see that Saturday and Sunday were by far the busiest planting days, just towering over the rest of the week. You literally don't even need to read the numbers to get the main story.
Next up, Section 5, Art in Data. Beautiful information. Now, before we get all artistic, we have to make a choice. Should our bars go up and down, or should they go left and right? Well, here's a pro tip. Match your graph to the real-world items you are actually measuring. If you're measuring the height of something that shoots up into the sky, like a person or a massive mountain, use vertical bars. But if you're measuring a length that runs parallel to the ground, like a really long river, it makes so much more sense to use horizontal bars. Let's take mountains, for example. We've got data for the tallest mountain on a few different continents: Mount Everest in Asia, Aconcagua in South America, and Denali in North America. Staring at the raw numbers like 8848 and 6194 in a plain table is a little dry, right? But by putting them into a vertical bar graph, we can instantly and visually compare them. And wow, that giant Everest bar just absolutely dwarfs the Denali bar. Okay, now let's level this up even further. When we take the time to beautify our data visualizations with artistic imagery to make them more engaging, we create something called an infographic. Think back to our mountain bar graph. Instead of boring plain rectangles, what if we made those bars look like actual colorful mountain peaks? Suddenly, you're looking at a mountain range. It totally grabs your attention, it's super pleasing to look at, and it communicates the exact same mathematical data in a way that's just so much more fun.
And finally, Section 6, Revision Quiz. Time to test those detective skills.
Okay, let's do a rapid-fire recap. Data is any collection of facts or numbers conveying information. Frequency is the exact count of how many times something occurs. We use tally marks to group things incredibly fast by fives. Pictographs use cool pictures and a key scale to show data, and bar graphs use uniformly spaced equal-width towers to help us compare numbers at a single glance. All right, here is your absolute final puzzle. We've got some real-world cricket data for the famous bowler, Jasprit Bumrah, showing the number of wickets he took across different matches. One side shows the number of wickets in a game, and the other side shows the number of matches where that specific thing happened, which, remember, is our frequency. Now, a student named Mayank takes a look at this and says, oh, to find the total wickets Bumrah took, I just need to add the numbers in that first column, 0 plus 1 plus 2 plus 3 plus 4. So, is Mayank correct? Think about it for a second. No way! He's making a classic rookie detective mistake. You can't just add the wicket numbers together. You have to multiply the number of wickets by the frequency, the number of matches. For example, if he took 3 wickets, but he did that in 8 different matches, you gotta multiply those. That means he took 24 wickets just from those games alone. You always have to multiply the value by the frequency to find the real total. Awesome job catching that mistake. You guys are officially master data detectives now. You know exactly how to organize messy facts, build tally tables, draw pictographs, and construct absolutely perfect bar graphs. Remember, we live in a massive age of information, and data is literally everywhere, just waiting to be understood. The only question left is, what real-world mystery are you going to go out and solve with your new data superpowers next? Keep exploring, stay curious, and I'll catch you on the next explainer.